Today, we're going to be going over one of the coolest parts of robotics, sensors. You may not know it, but we humans have sensors too, our five senses. Our eyes, ears, mouth, nose, and skin all help us learn about the world around us. Like us, robots depend on their sensors to learn new information and make decisions. Before we go over our code today, I'm going to go through a quick run-through of all the sensors you could use on your Mindstorm robot in real life, and we'll look at these same sensors on Scratch. We'll also talk about how people use these sensors to make robots that do jobs. The first sensor is the touch sensor, which does exactly what you would think it would do. In real life, this can be helpful in letting your robot know when it's hit something. On Scratch, we can copy this by using the touching something block. Which we can use to sense whether we've hit another sprite or an edge. The next sensor is a color sensor, which senses different colors. This can help the robot follow a line or tell where it is on the field. On Scratch, we can use the touching color block, or the color touching color block. An ultrasonic sensor sounds really fancy, but it really just tells you how far away you are from something else. This could be another way to tell if your robot is going to hit something, and this is represented by the distance to block on Scratch. So we see it right here. If you notice, this block is round instead of diamond. This is because this block isn't true or false like the other diamond blocks, so you have to put it into a diamond block with another value to get it to work. So if we look at this, if I click it, it tells me a number. Look at the However, if we were to look at the touching mouse pointer block, we can see that when I click it to run it, it tells us a true or false value. This means to use this particular block, you have to put it within another block. So for instance, you might say if the distance to the mouse pointer is equal to 50, that could be a conditional statement. To move on, a gyro sensor detects turning. It can help make your turns more precise or detect whether a robot has fallen over. This is kind of like the sensors inside the wheels of some robots, which detect how much it's spun. These sensors are called encoders or potentiometers, depending on what kind they are. We see these down there here. These two things are similar because they're very important in real life for making sure the robot is moving and turning as far as you want it to be. On Scratch, however, because it's online, we already know exactly how many steps we are taking and how far we're turning. There are some sensing details that only Scratch has because Mindstorms are designed to work autonomously, that is, to do things by themselves. Scratch is designed to talk to your computer keyboard and mouse so that you can do things like play games on it, so it has those features included. Scratch can sense when you press keys or click on sprites, and if we go up to the event categories, we can see that you can trigger certain lines of code to run when certain keys are pressed. Oops. For our project, we are going to code our Mindstorm to follow a line. So let's go back and to look at what you guys did yesterday. What does your code look like? Is it super long and complicated? Probably. The worst part of that kind of code is that if the field changes a little bit, you have to start over. So let's look at what I did here. I wrote all of this code out, and it took me a while, especially compared to the other projects that I've done so far in this camp. So when we run it, it works, mostly. The robot doesn't really hit any lines, but as soon as I change its starting place, or as soon as if I were to alter this maze ever so slightly, the entire conditions would change. I would have to start completely over. It would take me a while to make these numbers reliable again. We can use sensors to make our code simpler and shorter and to make it more applicable to more situations. Using sensors can help our robot make its own choices, and it can make decisions a lot faster than we can. But how do we make our robot make a decision? We use an if block, also known as an if-then block. If-then blocks are in the control category alongside our repeat blocks. There are two main kinds of if-then blocks and if-then-else blocks. These are also called conditional statements. So, an if-then block checks to see whether a condition is true, and if it is, it runs the code in that block. An if-then-else statement also checks to see whether a condition is true, and if it is, it runs the code inside this first space, and if it is false, it runs the code in this space. Like in our repeat until blocks, seen here, we use the diamond condition blocks, like our touching blocks, key blank pressed, or one of these operator statements, to describe what criteria the robot should be using. If we need to constantly be checking whether something is true, this is where a forever loop can be very important, because it will always make sure the robot has its eyes open if we want to compare the sensors to our own senses. Pick one of Scratch's sensing capabilities and use it to guide your robot through the maze. You're welcome to try it on your own, and if so, pause the video now. If you want some extra help, feel free to work alongside me. So I decided to use a color sensor to have my robot follow this green line here. The color sensing block on Scratch is pretty vague, and it'll be true if any part of the robot is touching the line. I'm talking about this block here. So that wasn't very helpful for me. If I could only tell whether I was still on the line, and as soon as I went off of it, I couldn't tell which direction I needed to turn back towards the line. So I decided to try to use two color sensors. And the way I did that is using the color blank as touching color blank block. This required me to create a new costume to my robot, which I happily did. So I'm going to grab that from my backpack now. So if we look at my new costume, it has a red blob on the left side of the robot and a blue one on the right side. The placement of these blobs means the robot will know which way it needs to turn to be back on the line. Otherwise, it doesn't know whether to turn left or right, and it can easily turn itself around. So in my code, I'm going to start a new block. I'll reuse this event block here. I'm going to tell it that if the red arm, I'm going to use this so that I know exactly what shade of red I'm using. If the red arm is touching the green, it should turn to the left, and if the blue arm touches the green, it should turn to the right. I'm going to actually use the if-else blocks so that the code is only run if those statements are not true. So it's only going to check to see if the blue is touching the green if we know for a fact the red is not touching the green. So we're going to add in our degree blocks here. So if red is touching it, we want to turn the other direction. We want to turn left. And if blue is touching it, we want to turn right. I'm going to have it do small increments so that it doesn't accidentally overshoot the line. And then obviously, if it's moved enough, if it's going straight on the line, we want it to move forward. Finally, well, you could probably use a forever loop and just manually turn off the program when it reaches the end of the line. That sounds like a little bit of an extra step to have to wait and watch our program and then stop it ourselves. So an easier option would be to use our repeat until block. So if I pop that in here, I'm going to get rid of this. We can tell it to stop once it hits the middle of the maze. So now we successfully created a program to follow a line. Let's try it out. I'm going to put it right here. I'm going to turn it around. Wow, look at it go. So normally this is about as far as we might make it with our Mindstorms in-person camp. Like I mentioned earlier, it's a lot harder to make precise actions with the robots themselves. Since we don't have to worry about that, we're going to spend the rest of our time exploring Scratch's functions. Feel free to spend as much time exploring on your own as you want. If you want structure, I'll be working through most of it, but you're also welcome to consult the videos as you see fit and mostly do your own thing. There are a lot of other fantastic resources on the internet too, so take a look at those if you so desire. With that in mind, let's try out some of the user-based sensors Scratch has. For me, I'm going to use the function that lets a sprite follow around the mouse pointer. In real life, this wouldn't really be possible on a Mindstorm, but online it's easy. I'm going to start out with my when green flag clicked block. I'm going to get rid of this code here because I don't really need it anymore. I already have it saved in my backpack anyway. I'm going to get rid of this huge long piece of code. I don't want to see that again. I'll put it in my backpack just to be safe. I'm going to start out with my when green flag clicked event block, and then I'm also going to grab a forever looping block. To make it so that my sprite always tries to follow around the mouse pointer. So in the motion category, we see the block that says, go to mouse pointer. Let's see what happens when we use this block. Make sure to disconnect any of your other code from the events box before running your new code, or the old stuff will interfere. So that worked, but not as well as I would like. It follows our mouse pointer, but too well. I want it to look like it's following it around. To get this effect, I can use the point at mouse pointer block. As we can see, when I run this, the robot will constantly look at my mouse pointer. When I add a movement block, like this, it'll follow it around. Now it looks like it's actually following around instead of just teleporting to its location. With 10 steps per block, it's pretty fast, but I can always lower it to reduce the speed. Let's see how it looks with only 5. So you can do a lot of stuff with Scratch. Today we learned about sensors, if statements, and getting our robot to make its own decisions. Tomorrow we will learn about other kinds of events blocks and the interactions between different sprites. I can't wait to see your projects, and as always, feel free to email me if you have any questions.